Goal with the presentation here is to try to highlight what does it mean to deploy at scale in large organization artificial intelligence applications. That's our area of focus at Element AI, and then I mean I've done my entire career doing that. Of course, 18 years ago was pretty simple. Simple algorithms, mostly massaged by people. And as time went by, the broad scope that opens up was something that we never thought possible, but it's quite exciting. So now we get to deploy capabilities in tons of new area. So it's pretty interesting times right now. About the business and quickly, so you get a sense. So small enterprise software business. We operate in 5 different cities around the world: Montreal, Toronto, London, Seoul in South Korea, and Singapore. We launched about 20 months ago. We're about 400 people, got about 90 PhD in artificial intelligence. We now have 7 or 8 different applications that we roll out into the market. Published about 45 scientific papers in the last 20 months. So just a few stats about the business. Really scaling up in terms of numbers of customer that we're rolling out in production. Lots of pain in the process. You would figure it's quite of a challenge, but also lots of very great learning. But one thing for sure. And that's really funny because almost everything changed about the business through the whole, last 20 and even plus months. The business model, we pivoted a bunch of times. The market that we were interested in, and every time we were getting feedback, like a lot of things were changing. But there was a few things that didn't change, and just to point them out because I think they're quite fundamental at this point. We've got so much, we've battle tested this so much that I think that it's something that everybody should be aware of. First thing to understand, the current world is a world where people and most of the IP in organization is captured by human brains. Even though that IP is then encoded into a software program, it's a human that thought about, hey, what are the interesting conditions that leads to a specific outcome? And then people have been programming that. There's smart program that are dumber, but yeah, it's like the point is that that's the bulk. That's the heavy lifting. The more you do that as an organization, whoever you are, the bigger your barrier to entry to then change things. So the more you code stuff, the more to change it will require a lot of work. So slowly, as you scale up, obviously, there's these big silos that are created. Cost of change becomes bigger. There's more friction. And this leads to a best practice known as, you want to scale, find like the Pareto principle, number of rules that works for your organization, make sure you capture the bulk of the value, and the rest, too bad. If you want to scale, that's how you preserve agility, that's how you preserve efficiency. We think that this is getting profoundly challenged. The information is often incomplete, so obviously because lack of accuracy, but also lack of human, the ROI is not there. So we could get more info, but like throwing more body at this actually creates more complexity. So these are fundamental problems. So I'm setting up my next slide. AI is the answer for all of that. The joking aside, AI is eating software. But that was our thesis from the beginning, and literally the way we are programming now is being transformed. So what does it mean? What does AI do? Like you describe an outcome for a model, you set a number of observations, and then you're going to reinforce that model in order to try to get to that outcome more and more efficiently by providing feedback. I'm describing reinforcement learning types model, I know, but like even with models that are not reinforcement learning, there's still like people in the loop that are kind of doing that. You throw more data sources at the model and then you try to get it to learn better, capture more IP, and then produce that outcome. And this is becoming amplified and amplified. It's a new way to code. You no longer write all the rules about how you should go at making a claim payment to your customers or managing your portfolio if you're trading. You no longer write all the situations that, if this happened and it's this state, then like look at this variable and then like we should pay less than whatever we've seen here. This is how we used to build all of these systems. And then the flexible systems were the ones that had, buttons and inputs that, non-engineer could actually massage and change. And that was it. But we're moving beyond that now. So we're programming these systems based on interaction we have with them and then based on the feedback we're providing. More importantly, it's much cheaper to scale. Once you've trained the model, you can copy it 1,000 times. I know it's obvious, but like we can do that now with stuff that used to be running in human brains. That's pretty cool. The progress we've made and the cost of capturing more data, more insights also enables us to perceive more stuff. So we can make sense of visual information. We can very easily categorize object, read stuff with OCR, object character recognition techniques. We can very easily understand speech, understand language, translate. We can understand signals. And I can go on with a very long list. Yeah, some of that stuff is state of the art and just was released like 3 months ago. But like we're knocking these very hard problems one after another at a speed that, at this point, the cost of capturing a snapshot of reality is like falling exponentially. So yes, it means more data. Yes, it means like that time series database are going out. I thought that it was a very interesting data point to support that. But more importantly, you can now start to use this in order to go further in automating prediction and automating decision. And really, that's really how we like to think about the future for enterprise software. So we're into a mode where we think that there's going to be a full replacement in the enterprise software industry where traditional systems that have been designed so that rules are encoded by someone, an engineer or someone that click on all the right switch are going to come to pass, and that we're going to enter a world where everyone in an organization will be interacting and providing feedback to smart systems that will learn and adapt and evolve at lightning speed. And that has a lot of implication. It has implication in the risk. So that's the reward. So that's pretty obvious, I think. It could be like extremely lucrative for a lot of companies, enables business model that were not even possible. But it brings a lot of risk too. So suddenly, if you provide the wrong feedback, how do you catch it? How do you see it? If you start rolling out at very, very large scale certain behaviors, that maybe at small scale, if it's humans that actually do these things, you're never going to see it like really create a mess. But suddenly, if like the AI picks up that whatever type of customer is particularly sensitive to this type of incentive and just start to apply this relentlessly to everybody, I mean, it's going to create a problem. And you're going to start to see like, a part of your business go wrong. So built-in biases and all of these types of risk that comes with the technology. So, you cannot take this into isolation. It has to be a full-blown, thought-through framework. How we think about this, and how we like to get our customer to think about this, the opportunity is that, hey, like how does this opportunity change the processes that you actually have? Like we're not much into like getting things 10% better. Yes, I know like, it's easy and you have quick wins, but the real opportunity resides in really transforming the way you do things. How does that change your price point? So is there a lot of cost built into certain a priori that you have and how you go at conducting business? Can you totally change your price point? Does that open new market? And is there a new product and services that you can actually package? Can you increase the level of personalization of whatever you're delivering? AI being able to figure out rules, giving sufficient volume, you can now decide to embrace complexity. You can go the other way, where everybody's tried to simplify it. You can suddenly start to go and actually complexify and be more precise. So these are the way that we like to get our customer to think about how to leverage this opportunity. So really, and this is an example of one of our product in claims processing for insurance, it's to take human-driven process that are prescribing rules and then shift it to AI-driven process. So in this case, and I don't know if everybody sees it really well, but for each of the different decisions, there's human in the loop and there's an AI driving the decision. And the idea in how we're thinking about every app, it's about a succession of decisions, and then we assess what are the different inputs that are required to drive that decision, and how does this connect to delivering the business outcome. And all of our products and everything we do is basically organized and orchestrated around these decisions. And we think that this is what's going to survive. Process are not going to survive this. Like, if you're focusing your business, my belief, a building of being able to gather certain input, it's going to be marginalized in terms of value contribution. What's going to be very valuable in the future as software provider and as businesses is having applications that solve these decisions and to see how this makes sense in the broad ecosystem of the business. We got a process that could be a full talk, like how we've got to this, how we design, how we go and do data audit, make sure that the models actually solve the right business decision, how do we prototype, deploy, operationalize, and then get our customer to be trained to do that themselves nonstop. But what's interesting are common mistakes, and I think there was a question about what are the risks with AI, and there's a few here. I just actually gave a talk this morning at the startup conference on the transformation from data governance approaches to AI governance, and it was touching on a few of these things. I'll be releasing a blog on the topic if any of you wants to learn a bit more about how to manage risk in deploying AI at scale. But just to point out a few here, one of the first biggest myths is that you have a lot of data, therefore there's value in there. And there's nothing more wrong than that. You absolutely need to have a targeted approach. So for one specific decision, how can you craft and gather feedback so that you capture the IP in your model or in your application? And then you got to figure out the IP goes where. And that's another interesting, funny question where there's a lot of friction about it. But the point is, like, these systems needs to be able to figure out the rules, needs to be able to self-improve. So you need to build that visibility, the contextual information that helps them measure their performance and drive the value at the end. Don't assume that because you have a lot of data that it will directly convert into value. We've seen this too often everywhere. Unclear governance. I was talking about biases. There's another one, completeness. Is your model basically perceiving the world as everything that the world is? Or there are blind spots? And if there's blind spots, can you bring a human in the loop to complete these blind spots or not? Or can you deploy IoT? Or how can you go with this? Can you involve your customer in the loop so you diminish the blind spots? But you need to at least ask yourself that question. Is the accuracy, what kind of performance should you get there? If you're running a call center, you're trying to predict the number of calls per minute, 70% accuracy, it's kind of good. If you're running a retail store and you're actually predicting your sales for the next week, if you have below 90%, your model is not good. So accuracy depends on use cases. Only trying to replace old tools, well, a lot of these tools have been typically designed around limitation because they were designed to be driven by humans and where engineers or experts, analysts, would prescribe the rules in some shape or form. So the limitation, the silo, the way they were scoped was designed for that. So to use this and say, oh, I want to replace like my optimization system that does inventory management and like the scope of the system is going to be the same one as the past, is the wrong approach to it. You're not going to capture the benefit of the opportunity of that technology. Finally, this being driven by one side of the business. The beauty with AI is that really, the people who are operating the business are going to be the people who program these systems. They're going to give the feedback. So, your CTO, your CDO, or your customer CDO, CTO have to be talking to the business people. They have to be talking to the governance people. They have to monitor the risk of these things because you're going to let them loose. You need to monitor them. You need to understand what's going on, and you need to make sure that all of these groups basically are in constant communication. And we see too often either the IT side of the company just going after something, or just the business people trying to do this. Like, you need to make sure your data is well prepared, and I mean all of the more technical stuff, you need to get it right. Because the level of automation you're going to reach with this can really hurt your business if it goes wrong. And that's it. Thank you.